va sin girar hacia ningún lado. Este video publicado en internet es un video grabado en el Museo Intiñán de la mitad del mundo en Ecuador, y en él hacen una demostración sobre el efecto Coriolis. Me pareció bastante curioso y quise reproducirlo acá en mi casa, y me encontré con que mi casa, ubicada en México, Distrito Federal, también pasa por el Ecuador. Vamos a ver cómo es eso posible. Bueno, pues resulta que mi casa está sobre la línea del Ecuador, así que hemos puesto un poco de agua aquí, vamos a colocar algunas hojitas y vamos a quitar el tapón para que vean que justo aquí el agua se va sin girar hacia ningún lado. Ahora, si nos vamos hacia el norte, vamos a movernos hacia el norte, vamos a poner el tapón y vamos a colocarle un poco de agua. ¿Sí? Y si colocamos algunas hojitas y quitamos el tapón, vamos a poder ver que el agua gira hacia la izquierda, ¿lo pueden ver? Y ahora si nos vamos hacia el sur, de este lado tenemos el sur, en nuestro Ecuador, vamos a tirarle agua. ¿Sí? Colocamos igual algunas hojitas para que se vea el sentido del agua y vemos que ahora el agua gira a la derecha. Bastante impresionante, ¿no? Mentira, la Ciudad de México está más o menos a unos 3.000 kilómetros del Ecuador y fui capaz de reproducir este experimento. Entonces, ¿cómo pude hacer este mismo experimento en casa? Bueno, la explicación es la siguiente. Si analizamos el video, lo único que hace la diferencia es el lado por donde se tira el agua. Si lo revisamos bien, podemos ver que cuando está en un hemisferio u otro, el agua la tira del lado izquierdo o del lado derecho, y eso provoca que el agua gire en ese sentido. Al vertir el agua desde uno de estos lados, se induce una corriente que, aunque no se ve, el agua se mantiene moviendo. Al principio del video, el agua ya lleva en reposo algunos minutos, y es por eso que al retirar el tapón lentamente, el agua baja sin...
Triangles. If you walk 10,000 kilometers straight along the Earth's surface, turn 90 degrees to your right, walk 10,000 kilometers more, turn right again, and walk another 10,000 kilometers, you'll be back to where you started, having successfully made a triangle with 3 90-degree angles. As any geometry student can tell you, this is impossible on a flat surface.
Now, if we were Eratosthenes' friends and wanted to do the same thing with the sun in real life, our experiments would fail. We would not be able to triangulate the sun. The cones or the lines that we would draw to triangulate the sun would not intersect in one point like in the 3D model that I just showed you. And this is going to make us think that the Earth is not flat, because the triangulations worked on the experiments that we did on the flat table, but did not work on the sun in real life. So something must be wrong. You would think, what is it? This must mean that the Earth is not flat. So if we really were those scientists, you would have to think about something else, like the Earth being a globe, for example. Yeah. So this is how they came up with the globe theory. The angles of elevation led them to think about the globe model. They were just assumptions based on mathematics. Forgive me, but I'm going to say this one more time. If you use more than 3 positions to triangulate the sun, assuming that the Earth is flat, your triangulation will never work. No matter how hard you try, you will always fail. The sun rays will never intersect in one point. I have been doing this for a long time and I had to come to this conclusion. Some of you might think that if the distances between the objects are not accurate, then the triangulation will not work, and I agree with that. But even if the distances were 100% accurate, the triangulations would never work, and I'm gonna prove what I'm saying with another experiment. As we said in the previous videos about refraction, the sun is never in its real position. Even modern science agrees with us. What you are triangulating is a reflection of the sun, and this is why your triangulation will never work. Imagine yourself in the bottom of a swimming pool trying to triangulate a bulb that is above the water. You will never be able to triangulate it unless you know how refraction works on water. The experiments will explain this better. Just stay with us. So, Eratosthenes and his friends decided that the Earth is not flat, because there was no way to make the angles of elevation work and make sense. For example, whenever they triangulate the sun from 2 positions, the distance to the sun appears to be around 3,000 miles. And at the same time, they triangulate it from 2 other positions and they get a distance of 4,000 miles. Solving this at that time was impossible, and it was still impossible to us until a few months ago. Anyways, these mathematicians had to find a way to make these angles work, so they assumed that the Earth is a globe and the sun rays come to Earth in parallel lines, because this was the only way to make the angles work. So their only problem was how to know the circumference of the Earth so that angles can work perfectly. Eratosthenes supposedly had this brilliant idea. There was a well in Syene in Egypt, and the sun used to pass directly above it once a year, which means that the sun at that time was 90 degrees above that well. The next year, at the same time and date, he went to Alexandria and he placed a stick on the ground, and he noticed that the stick had a shadow. So he measured this angle of deception, and it was 7.2 degrees. So he thought that the Earth must be a sphere and that he could calculate it. He just needed to know the distance between Syene and Alexandria. So he sent a guy to measure the distance, which was about 5,000 miles or 800 kilometers. So this angle right here, 7.2, has to be equal to the central angle of any sphere, and that made everything else easy for him. A sphere is 360 degrees, so all he had to do is divide 360 by the angle of deception, which was 7.2 degrees, to get 50. So if we draw a circle like this, and draw a line like this, and repeat it 50 times, it will give us this angle, 7.2 degrees between each two lines. So in order to get the circumference of the Earth, he had to multiply 50 by the distance, which was 500 miles, and he got 25,000 miles or 40,000 kilometers. So that has been the circumference of the Earth since that time, which is really precise for someone who had no equipment at all. Very smart move, NASA. All you had to do was correct the calculations a bit more.
What's going on, everyone? It's Jaron.
Number 5. The stars at night change as you go north or south. For example, Orion is upside down if you're in Australia. Number
celestial rotation around Polaris. Well, what I want to show in this video is that it's not its own rotation, but is in fact just a perspective illusion. It's an anti-rotation, in the same way that anti-crepuscular rays are anti-crepuscular. Okay, and they converge on the opposite horizon to a point, much like when they come from the sun. They come and they diverge out and then they converge on the opposite horizon. Well, the southern celestial rotation is nothing but an anti-rotation of the northern celestial rotation. We can only see the dome of our perspective vision, which is about a 12,000 mile diameter circle or 6,000 mile radius. That's all the stars we can see. And the stars lower to the horizon at the edge of that circle, of a 12,000 diameter circle. So as you move, this dome of stars moves with you, or your dome of vision, I call it. Anyway, let's check it out. Well, just like, let's say you're standing at the North Pole, right? And the stars rotate. You have Polaris overhead, and the stars are rotating around you counterclockwise. As you move south, Polaris starts to lower in the northern sky, and the stars start to tip. It's almost, I like to think of it as like a salad bowl, right? And so the salad bowl has the bottom is up, that's where Polaris is, and the rim of the bowl is on the ground. That's also where the sun would go around, from your perspective at the North Pole. So as you head south, the solid bowl starts to tip onto its side, and so that, let's say you travel 3,000 miles south of the North Pole, everything would be rising in the northeast, sweeping out over the southern sky, and setting in the northwest, like this, right? And if you go all the way to the equator, Polaris would now be sitting on your northern horizon, the solid bowl would be completely tipped on its side, and half of it would be below the horizon, and now all the stars would be coming up east to west, and so the sun would also rise east to west. And now that's a hard one to visualize. Because if the stars are all rotating like a big disk around Polaris in the sky, a big flat disk, or if they're not a disk, they're a big dome, whichever one they are, if that's the case, and if it's a big flat disk and it's just a perspective that's bringing the stars down, well then the people in the south say, hey, well the stars should be rotating just above the horizon, right? And stay equidistant to the horizon as they go around.
Finish him!
We know the Earth is round because we have photographic evidence.